In the spring of 2025, the two most powerful pieces of software in the semiconductor industry were not chips, not fab equipment, not even the machines that etch silicon. They were design environments built by two American companies, Cadence and Synopsys, and without them, a chip does not go from idea to silicon anywhere on Earth. Washington told China it could no longer use them. 6 weeks later, Washington changed its mind. Beijing called that a folded hand. The question is whether that reading is right, and who actually walked away with the heavier prize. The bullish claim runs like this. China identified the counterlever before the ink dried, applied it, and forced a reversal so fast that domestic substitution was not even the driver. The reversal preceded any meaningful Chinese alternative reaching production scale, which means Beijing cashed its chip through pressure alone. The skeptical counterclaim is equally direct. The tools that were restored are not the tools that matter at the frontier. The leading-edge software that defines who can design the most powerful artificial intelligence accelerators and the next generation of data center silicon, the tools that operate below the 7-nanometer threshold, those were never unconditionally released. The scorecard looks different depending on which battle you think is being fought. 3 rounds decide this. The first is about leverage and who held it. The second is about domestic substitution and what the 6-week window actually built. The third is the round the skeptics win, and it is the heaviest one on the card. The leverage argument begins with geography that predates the ban by decades. China processes the dominant share of global rare earth refining capacity, particularly in the heavy rare earth elements that defense manufacturing and advanced semiconductor production depend on. That fact is not a projection and not a company claim. It appears across public trade data and government supply chain assessments from multiple countries. The specific share varies by element and by year, but the direction of the dependency is not seriously contested. When Washington moved against Cadence and Synopsys access in the spring of 2025, Beijing made clear, according to contemporaneous reporting, that interdependence ran both ways. Reports at the time cited rare earth leverage in the same breath as the restored access. No official United States government confirmation of a formal trade was made public. That caveat matters. The causal link between the rare earth signal and the restoration is analyst inference, not confirmed policy record. What is documented is the timeline. Approximately 6 weeks between restriction and reversal, a window too short for domestic substitution to explain the change. The counterclaim on the leverage round comes from the diplomatic context. The restoration did not happen in a vacuum. It arrived during a broader period of de-escalation across multiple simultaneous tracks, including tariff negotiations, trade talks, and supply chain conversations that predated the EDA restriction by months. Washington may have run a cost-benefit calculation that found the ban creating more friction with allied semiconductor industry stakeholders and more disruption to American firms with Chinese customers than it was generating in strategic delay. That would make the reversal a policy recalibration, not a response to a specific Chinese threat. Correlation between rare earth signaling and the timing of the reversal is real. Causation is not independently documented. The evidence, taken together, awards this round on tactics, not on proof of a formal deal. China identified the pressure point. The timeline compressed before Washington could consolidate the position. Whether the mechanism was an explicit trade or an implicit calculation that the ban's costs outweighed its benefits, the outcome is the same. The restriction did not hold. Round 1 goes to China, with the explicit caveat that the mechanism remains unconfirmed, and the round is scored on observed behavior, not on a documented concession. The second round belongs to what happened inside the 6-week window, and here the evidence is more concrete and more uncomfortable for the restriction's architects. UniVista, a Chinese EDA firm that had been operating in the shadow of Cadence and Synopsys, ran what industry observers described as a free trial counteroffensive during the ban period. Chinese chip designers who suddenly needed an alternative were offered the tools at no cost. Empyrean Technology, a publicly listed Chinese EDA firm with disclosed revenue figures, drew visible analyst and press attention during the window, its trajectory accelerating into a moment when the alternative to domestic tools was operational paralysis. Xpeedic, another domestic player, covers a narrower segment, focused on high-frequency and radio-frequency design work, which matters when assessing how broadly domestic tools can substitute across the full range of chip design tasks. The industry shorthand that emerged from the window was a phrase: domestic EDA is now good enough for 7-nanometer and above. That phrase appeared in industry analyst notes and Chinese technology press. It has not been confirmed by an independent tape-out benchmark or by a major foundry's public process qualification statement. That qualification is the counterclaim's entry point. Good enough for 7-nanometer and above is a claim made by firms with a commercial interest in making it, during a period of maximum urgency when the alternative to claiming adequacy was admitting vulnerability. The meaningful test of domestic EDA capability is not whether a design house can run a flow on a mature node in a controlled demonstration during a 6-week window. It is whether Chinese fabs can tape out chips at volume, on schedule, without cadence and synopsys, and sustain that capacity across multiple product generations and process shrinks. That test was not run because the access was restored before it had to be. The free trial counteroffensive demonstrated that domestic tools exist and can be deployed under pressure. It did not prove they can replace the full capability stack. A full EDA flow is not a single program. It is something closer to an entire construction crew: architect, surveyor, structural engineer, site inspector, code reviewer. Domestic Chinese EDA firms have credible architects and surveyors, the structural engineers for the most demanding work. The tools that handle the physical verification, time enclosure, and process design kit integration at the most advanced nodes are still Cadence and Synopsys. That crew analogy is the only one this script will offer for the abstraction, and it earns its place because it clarifies why good enough for 7-nanometer and above is simultaneously a real achievement and a confession about where the ceiling sits. Round 2 goes to China, with that asterisk attached. The ban accelerated exactly the import substitution it was designed to prevent. Engineering teams that might have stayed on American tools out of workflow inertia were forced to stress test domestic alternatives under live conditions. The acceleration is real. The ceiling is also real, and the ceiling is where the third round lives. The Skeptics round begins with a definitional question that the folded framing skips. A 6-week restriction that ends in restoration is, by any plain reading of the word, reversed. The argument that it represents a concession on signaling grounds is analytically coherent. Export controls derive part of their power from the credibility of permanence, and a temporary ban that reverts is not a ban. It is a negotiating position that got called. If that logic holds, the signal sent to China, to allies, and to the firms that lobbied against the restriction is that the tool has limits. That signal is real, and its effects on future enforcement credibility are not trivial. But there is a distinction between restoring access to mature node EDA tools and surrendering the leading-edge chokehold, and conflating the two is where the folded framing overclaims. The tools that Cadence and Synopsys develop for designing chips at the frontier, the process nodes below 7 nanometers where artificial intelligence accelerators, the most advanced mobile processors, and next-generation data center silicon are designed, were not the subject of an unconditional restoration. China's domestic EDA capability at those nodes remains unproven on any public, production-scale, independently validated basis. The chips at the center of the technology competition between the United States and China are designed at nodes where no credible domestic Chinese substitute exists by current public evidence. The reversal on mature node access may have been a calculated release of pressure precisely to preserve the credibility and the coalition support needed to hold the restriction where it actually constrains the outcome. Retreating from ground you can afford to give is not the same as retreating from ground you cannot. Follow the protagonist through the chain, and the picture sharpens. A chip design begins as a concept in an engineering team's head. It moves into an EDA environment where logic is synthesized, timing is analyzed, physical placement is computed, and the final layout is verified against the foundry's process rules before a mask set is cut and silicon is fabricated. At a mature node, 7 nanometers and above, the domestic Chinese tools can now participate in meaningful portions of that chain. At a leading-edge node, sub-7 nanometers, the process design kits are tighter, the physical verification requirements are more exacting, and the tools need deeper integration with foundry processes that themselves depend on equipment from a small number of non-Chinese suppliers. Cadence and Synopsys sit at that integration point. Their tools are validated against the process rules of the world's most advanced foundries. Domestic Chinese alternatives at that level have not demonstrated the same validation publicly. The chip does not tape out until the full crew shows up, and at the leading edge, the crew still needs those two firms. The strongest reasons the skeptics' verdict could be wrong deserve equal time, because they are genuinely strong. First, the claim that the restoration preserved the leading-edge chokehold rests on the assumption that the United States can maintain that distinction cleanly over time. Export controls are not static instruments. They erode through workarounds, through allied non-compliance, through interpretation drift, and through exactly the domestic substitution pressure that Round 2 documented. If China's domestic EDA firms use the mature node window to build engineering talent pipelines, to attract the researchers who understand the hardest verification problems, and to accumulate the process knowledge that translates from generation to generation, the gap at the leading edge narrows by attrition rather than by a single breakthrough. The skeptics win Round 3 today. The durability of that win depends on active maintenance that a 6-week reversal did not strengthen. Current evidence does not show that domestic Chinese EDA is closing the sub-7-nanometer gap rapidly. But the attrition dynamic is real, and the timeline for that attrition is not infinite. Second, the reversal damages export control credibility, regardless of the strategic intent behind it. Firms that began shifting supply chains and engineering workflows away from American tools during the ban period now face uncertainty about whether the next restriction will also revert. That uncertainty does not have a single direction. It may slow Chinese substitution investment if firms conclude that restrictions are too unstable to justify the disruption of switching. Or it may convince Chinese firms that American export controls are too politically volatile to treat as a permanent architectural constraint, and accelerate domestic investment as a strategic hedge. The credibility cost is real either way, and it is not fully priced into a clean skeptic's win. Third, the terms of the restoration are not fully public. There is no independent record confirming that what was restored carried the same scope, the same tool categories, the same node ranges, and the same end-use certifications as the pre-ban access. If the restoration was partial, covering certain tool families while preserving restrictions in others, then neither folded nor held the line is fully accurate. Both sides are arguing about terms neither has fully disclosed. The burden of that uncertainty falls on both claims, and it means the verdict in all 3 rounds carries a load-bearing caveat about what is actually known versus what is inferred. Weigh those 3 challenges together, and the synthesis is uncomfortable for everyone. The skeptics win Round 3 on the evidence that exists. The evidence that exists is incomplete. The credibility cost is real and ongoing, and the attrition mechanism means the chokehold the skeptics are defending is not a passive asset. It requires active work to maintain, and a 6-week reversal did not make that maintenance easier. The verdict holds today. Its durability is the open question, and no one currently sitting in a policy chair has a clean answer to it. Score the full card. 2 rounds go to China. 1 goes to the skeptics. The skeptics won the heaviest one. China forced a 6-week reversal, used the window to accelerate domestic EDA investment in ways that will compound past the reversal, and demonstrated that export controls on mature node tools are politically reversible when counter-leverage is applied with enough speed. Those are real outcomes with real strategic value. The skeptics are correct that folded overstates it. The leading-edge EDA capability, the software stack that a chip designer needs to build the artificial intelligence accelerators and next-generation processors that define the competition's actual stakes, was not surrendered. Cadence and Synopsys remain the only firms whose tools are validated against the most advanced foundry processes on Earth. The reversal was a concession on the battlefield that already existed. The battlefield that will determine the outcome is the one where China has not yet built the equivalent force. On paper, China forced a 6-week climb down. In practice, it won the mature node exchange and still has not demonstrated it can fight the leading-edge war. The restriction designed to settle China's chip design dependency instead clarified the terms of the contest more sharply than before it was imposed. China can now contest the design terrain at 7 nanometers and above without American software. The United States still controls the terrain below that threshold. A band that was supposed to compress the playing field drew the boundary more precisely than anyone had publicly mapped it before. Cadence and Synopsys remain essential, not because the band proved their leverage, but because the reversal proved the limits of that leverage at exactly the nodes where their leverage no longer defines the outcome. The floor of the chokehold rose. That is the most precise measure of what the 6 weeks actually settled, and it is the measure neither side is advertising. The round that was fought went to China. The round that has not been fought yet is the one worth watching. Tell me which round you think scored wrong. If the restoration terms were partial enough to undercut the Skeptics case in round 3, or if the attrition argument in the dissent block should have flipped the card to a draw. Make that case in the comments. The evidence is incomplete on both sides, and the verdict is genuinely contestable. If this breakdown was useful, subscribe and turn on notifications. The next move in this fight will come faster than the last one did.